Assalamualaikum warahmatullahi wabarakatuh. Today we will discuss our last lab topic, which is separately excited DC motor, top speed, characteristic of single phase half and full control rectifiers fed separately excited DC motors. So for pre-lab work, number one, draw the block diagram of DC machine operate as a generator and as a motor. As we know, the DC machine operated from electrical input so into DC motor, then mechanical as the output. So here the DC generator circuit, and another one is DC motor circuit. We can identify the DC generator uh, by indication of the current flow, and also the DC motor by indication of the current flow to the motor. Question number 2, state the difference between self-excited and separately excited DC machine. Self-excited DC machine has a direct connection between field and armature circuits. The coil gets the excitation voltage from the voltage generated in it after a time period, but not in the starting itself. So it works on its own feedback. While the separately excited DC machine, it has no direct connection between field and armature circuits. An external supply is a must for supplying exciting voltage to the coil, and it needs external source to work. Question number 3, draw the equivalent circuit of a separately excited DC motor. So here the equivalent circuit taken from the textbook. Number 4, list down the various methods of speed control of DC motors. Number 1, field flux control method. Number 2, voltage regulation method. And number 3, armature resistance control method.
For experiment 1, the aim is to develop a program to plot torque speed characteristic of single phase half control rectifier fed separately excited DC motor. So, the speed of the DC motor can be maintained constant by adjusting the motor terminal voltage as the load torque change. If an additional load torque is applied, the motor speed momentarily decrease and the speed error increase, which increase the control signal. The control signal increase the converter output voltage, and increase in the motor armature voltage develops more torque to restore the speed of the motor. After we run the coding, this is the output, and for the firing angle 30 degree, 60 degree, 90 degree and 120 degree.
For experiment number 2, we need to develop a program to plot torque speed characteristic of single phase full control rectifier fed separately excited DC motor using Scilab. So the code already given. Then we type the code and make sure no error. So then we execute. The result is shown below. So the result for the black line, which is firing angle at 30 degrees, and the blue line for 60 degrees, the green line for 90 degrees firing angle, and the cyan line for 120 degrees.
For the discussion, it is based on the experiment. So we have plotted the torque speed characteristic of single half and full control rectifier fed separately excited DC motor using Scilab software. And then torque speed clearly has both linear and non-linear zones. And in non-linear and linear regions, this output clearly indicates the discontinuous and continuous operation of a single phase half wave converter drive. However, for varied firing angle, The non-linear and linear functioning areas are readily observable in a fully controlled rectifier. As the firing angle increases, so does the linear operating range of single-phase semi-converter drive. In order to study the effect of armature voltage on torque speed curve, 4 different firing angles are used. With the voltage provided to the field circuit remaining constant, the input of a single-phase half-wave converter is fed with a constant voltage source. The firing angle is used to adjust the average value of the converter output. And to change the firing angle, a cosine firing angle scheme is used. Firing angles were employed to achieve various armature output voltage. We can observe that the longer the delay angle, the higher the probability of success. Reduce the output voltage mean value, however the output value was never negative with the resistive load. And thank you.